7.2, we're continuing the inverse trig functions. We're going to be looking at composite functions still, but instead of it being sine, sine, cosine, cosine, tangent, tangent, we might have two different trig functions put together. And that actually makes this a lot easier. I am going to do all four examples in this one video, so it is going to be a lengthy video. Only watch what you need to watch. You do need your unit circle out with you. We will not be using our calculator at all during this section. All right, so finding the exact value. It is going to be very helpful if you can remember when a value is on your unit circle or not on your unit circle. You will not be told whether it is on the terminal side of theta or if it is on the unit circle. It is now time to start recognizing when something is on the unit circle. When we are working with these composite functions with two different functions, so like here in A, we have sine and tangent together. We always start on the inside. So it was very important that you guys did do your work from 7.1, example 1 specifically, where we did find the exact value. So I can take the tangent inverse of -1 and set that equal to theta. Now I switch these. I want to undo the inverse. So tangent of theta equals -1. That is a value that I recognize from my unit circle. This is on my unit circle. Because this started with tangent inverse, you are going to look in quadrants 1 and quadrants 4 only. Tangent is negative in quadrant 4. So look at quadrant 4, please, and find where is tangent negative. Tangent is negative at 7 pi over 4 or negative pi over 4. So I want the sine at negative pi over 4, or you can consider this the sine of 7 pi over 4, because that has no bearing on your answer. These are the exact same location. The sine at 7 pi over 4 is negative root 2 over 2. It's the same for both of those since they're at the exact same spot. There's my answer. I'm finished. So much easier than yesterday's. So I'm going to start B. I'm going to go ahead and get these switched. I'm not going to keep showing all of this work. We need to be doing the practice so we're understanding where some of this mental math is coming from. So this is going to be the sine theta equals -1/3. That is not on your unit circle. So we need to now remember that sine of theta is y over r. So you have your y is -1, and r is 3. We need cosine. That's what we're trying to find. We want cosine of this value. So cosine is x over r. We have y and r, we do not have x. So x squared plus -1 squared equals 3 squared. X squared plus 1 equals 9. X squared equals 8. Now when I square root this becomes 4 times 2. The square root of 4 is 2. So x is not plus or minus. X is 2 root 2. Please be careful with this. You are in quadrants 1 and 4. The x value is positive in quadrants 1 and 4. So don't make the mistake where I almost put plus or minus. It is plus only. X is positive in quadrants 1 and 4. I know I'm in 1 and 4 because it's inverse. This is quadrants 1 and 4. So cosine is x over r. X is 2 root 2. R is 3. There's your answer. Let's continue. If you need to watch it again, watch it again. Cosine of theta equals -1/3. X is -1. R is 3. Tangent is y over x. We don't have the y value. So -1 squared plus y squared equals 3 squared. 1 plus y squared equals 9. Y squared equals 8. So we get the same thing. Square root y equals 2 root 2. I'm not going to go over that again. So tangent of theta is y over x. Y is 2 root 2. X is -1. So we have -2 root 2. That is the answer for C. Tangent of cosine inverse of -1/3 is -2 root 2. All right, let's move on to D. Get rid of some of this here so I have room. Start with the inside. Cosine theta is -√3/2. That is on your unit circle. We need to recognize this. Please recognize this. So this is quadrants 1 and 2. Cosine inverse is from 0 to pi. Quadrants 1 and 2. So we need to look where is cosine -√3/2, and that is in quadrant 2. So look in quadrant 2, where is cosine -√3/2? And that happens at 5 pi over 6. So I want the cosecant of 5 pi over 6. If you don't have this on your unit circle or your trig chart, you have some work you're going to have to do. Secant is the reciprocal of sine. Sorry, cosecant. Cosecant is the reciprocal of sine. So you would have to find the sine, and here sine of 5 pi over 6 is 1/2. So then you would have to take the reciprocal. But if you already have this on your unit circle for 5 pi over 6 and you go to cosecant, you see that this gives you 2. Otherwise, you have to take the reciprocal of 1/2. So you'd have a little bit more thinking and a little bit more work that you need to do. Now I'm going to move on. I'm going to start here. Tangent of theta is 1/2. I do not have a tangent of 1/2 anywhere on my unit circle. I have some work to do. Y equals 1, x equals 2. Cosecant goes with my sine, so cosecant is the reciprocal of your sine value, or it is r over y. So you could either find sine and then take the reciprocal, or you can find r and y and then just plug in. Either way, you have to find r. So 1 squared plus 2 squared will equal r squared. 1 plus 4, so 5 equals r squared, so r equals the square root of 5. Since tangent is positive and my radius, it's always positive, I don't have to worry about signs. Cosecant is r over y. My radius is √5. My y is 1, so I have just the square root of 5. Please don't overthink these. They're not as bad as they might seem. Again, you need to practice. You might need to watch this a couple of times as well. But also come ready with questions to be asked when you guys are struggling, please. All right, let's move on with F. So sine of theta is 2 √5 over 5. And I need to find secant. Secant is r over x. So I have y over r. Y is 2 root 5. R is 5. So let's find x. X squared plus 2 root 5 squared, please use parentheses, equals 5 squared. Here you have to distribute. This is 4 times 5. 2 squared is 4. Root 5 squared is 5. So x squared plus 20 equals 25. Move the 20. X squared equals 5. So x equals the square root of 5. Okay. Secant of theta. R over x. R is 5. X is root 5. Hopefully you are thinking we cannot have the square root in the denominator. It's irrational, so we have to make it rational. 5 times root 5 is 5 root 5. Root 5 times root 5 is 5. 5's cancel, and we are left with the square root of 5. All right, I think that wraps up example 1. Let's move on to example 2. We're going to start looking at the inverse of the 3 cofunctions, secant, cosecant, and cotangent. Pay attention to their range. Secant has the same range as cosine, and that makes sense because secant is the cofunction of cosine. Cosecant has the same range as sine, they're cofunctions. And then our cotangent, that's the tricky one. Cotangent doesn't have the same range as tangent. It has the same range as cosine, 0 to pi, and that's because the graph. If you look back at your foldable for cotangent, the graph for cotangent is from, the first cycle is from 0 to pi. You have an asymptote at 0 and you have an asymptote at pi. That is your first cycle. So that is our range for cotangent inverse. And it goes with cosine, something we're going to need to make sure we remember. So example 2, finding the exact value. You need your unit circle for this, and if you don't have these 6 trig functions on your unit circle, you need to print one, you need to Google, or you're going to have some work to do. All right, I'm going to set this equal to theta, just like in 7.1. So then I can switch these because I want to undo the inverse. So cosecant of theta will equal root 2. If you do not remember if you don't have these on your unit circle, there is some work that you are going to have to do. Cosecant goes with sine. So you can actually find the sine of theta, which is the reciprocal. So 1 over root 2, then you have to rationalize the denominator, and you get the square root of 2 over 2. So now you have to find where is the sine root 2 over 2, and that happens at pi over 4. But wouldn't that be so much easier if you actually had this on your unit circle or you had a trig chart to reference? From here, you can use your unit circle. Find where cosecant is root 2. And since cosecant goes with sine, you are also looking in quadrants 1 and quadrants 4, just the right side of your unit circle. All right, let's move on to example B. For example B, we have secant. So I'm going to switch this around. So secant of theta equals 2 root 3 over 3. If you, again, have your unit circle or your trig chart ready to go, you can very easily find your answer. Secant goes with cosine, so you're looking at quadrants 1 and quadrants 2. Specifically quadrant 1 because it's positive. Let me address that back in A. Since root 2 is positive, you're also looking in quadrant 1. So that helps narrow down your search so you know which quadrant you're looking in. So if I look at quadrant 1 and I'm looking for secant, my secant is 2 root 3 over 3 at pi over 6. If you don't have your unit circle, you have some work to do. So you have to say, or remember, okay, secant goes with cosine, but it's the reciprocal. So 3 over 2 root 3. Oh man, we have to rationalize the denominator. So now I have 3 root 3 over 2 times 3, because the square root of 3 times the square root of 3. Those cancel. Root 3 over 2. Now you have to remember, where is cosine? Root 3 over 2. And cosine is root 3 over 2 at pi over 6. You get the same answer, but you have more work to do. All right, these next three, they're the same. So I'm not going to spend as much time going over these. I'm not going to do the work like I did here. I'm just going to use my trig chart. We need to practice using the trig chart. And if not, again, you have work to do. Cotangent theta is negative root 3 over 3. Cotangent, remember, goes with cosine. This is quadrants 1 and quadrants 2. Since it's negative, you're looking in quadrant 2. So if I go to quadrant 2, actually, I'm going to show the work. I'm not going to spend too much time with the unit circle because it is good to know how to do this. So if you are using your unit circle, you look in quadrant 2. Now, to do the work, cotangent goes with tangent. Tangent of theta, my guess is if you don't have cotangent, you probably don't have tangent, is going to be negative 3 over root 3. Rationalize the denominator. You have negative 3 root 3 over 3. So you have negative root 3. And the tangent is negative root 3 in quadrant 2 at 2 pi over 3. All right, moving on. Secant theta is negative 2. Secant goes with cosine, so this is quadrants 1 and quadrants 2, specifically quadrant 2 because it's negative. You can use your unit circle. You use your unit circle, you're looking at the second quadrant for secant, and immediately you will know that it is 2 pi over 3. Otherwise, you can work with cosine, and the reciprocal is negative 1/2. And the cosine is negative 1/2 at 2 pi over 3. Moving on, cosecant of theta is negative 2 root 3 over 3. I am just going to use my unit circle here so this video doesn't keep going on forever and ever and ever. Cosecant goes with sine, so that's quadrants 1 and quadrant 4. Since it's negative, sine is negative in quadrant 4. So you should be looking at quadrant 4, go to cosecant, we're looking for negative 2 root 3 over 3, and this is 5 pi over 3. Again, you can do the work, rationalize the denominator, and you end up getting the sine to be negative root 3 over 2, which then leads you to 5 pi over 3. All right, example 3. This is a nice little brain break. You're going to use your calculator. If you look at your calculator, you do not have a secant, a cosecant, or a cotangent button on your calculator. So we need to convert this into something that we know: sine, cosine, and tangent. So secant goes with cosine. Cosine inverse. But just like I did back here, what did I have to do? Every time I switched to the cofunction, I had to take the reciprocal. Every time I took the reciprocal. So what is the reciprocal of negative 3? Negative 1/3. Now you can use your calculator. You already have these worked out in your notes, so just practice using your calculator right now. This would be cosine inverse negative 1 divided by 3. Make sure you use parentheses. Cosecant goes with sine. So sine inverse, the reciprocal of -3 again, is -1/3. Plug that into your calculator. Cotangent is tricky. We need to remember, cotangent, you must use cosine inverse. But we need to remember cosine inverse is going to be x over r. With cotangent, you have x over y. You don't have r yet. So you do need to find r. So we're going to have, and it doesn't matter which one you make negative. You can make the x negative. You can make the y negative. Because we're going to square them in the end. So it's not that big of a deal what you guys do here. So I'm just going to say -3 squared plus 2 squared equals r squared. Again, you could say 3 squared plus -2 squared equals r squared. But it is the x that is squared because cotangent inverse is quadrants 1 and 2, and the y is always positive in quadrants 1 and 2. So this is 9 plus 4, which is 13. So I would square root that. R is the square root of 13. So cosine inverse, we're going to plug this in. Sorry, cosine theta. I didn't mean to put the inverse there. So cosine inverse of x over r, x is -3. R is the square root of 13. Again, the negative is not going to kill you because cosine is an even function. So the negative will not matter if you forget to put the negative. If it was sine, it does matter. Tangent matters. But for cosine, it is not going to matter. So now you would plug this into your calculator. Practice doing that. All right, example 4. Our last example does have 3. Now, we need to remember some of the identities that we did discuss in chapter 6. We need to remember what equals those Pythagorean identities. Oh my gosh, those are so important right now. They should be on the back of your unit circle. And if you do have that available to you, flip that over and find those Pythagorean identities. There are other things that we are going to need to remember for this, but this is just an introduction to what is coming ahead in 7.3 through 7.8. When we start establishing identities, and you are going to be taught so many different identities, it's just going to seem like a jumbled mess. But you are going to have to keep them organized, and you are going to have to remember back to them and not forget them. You're constantly going to have to keep looking at every identity as you are learning them. So here, we want to write each trigonometric expression as an algebraic expression in U. That means we do not want cosine or tangent or sine or secant or cosecant or cotangent at all. We want to rewrite them only using U. So I'm going to start with the middle, just like we did in the earlier examples. I'm going to switch this. Tangent theta equals U. What this means is everywhere I see tangent, I can now replace it with U. The frustrating part is now cosine. We have to rewrite cosine with tangent of theta, because then I can replace it with U. So let's see. I'm going to take cosine of theta, and we need to rewrite cosine of theta. So let's think. This is where it gets tricky. Well, cosine has a cofunction. Cosine's cofunction is secant. So cosine is the same as secant of theta, but it's 1 over secant of theta. Now look at those Pythagorean identities. And this, you guys, is a reciprocal identity that we went over in chapter 6. So reference that. Look for that right now on the back of your unit circle. It should be there. Or the front, wherever it's at. So cosine is 1 over secant. Now, if you find your Pythagorean identities, we have a Pythagorean identity that says 1. Oh, I don't remember if it is and I did not bring my Pythagorean identities home. And here I am telling you guys that you need to have your Pythagorean identities out. Give me a minute. I need to look it up. All right, I found it back in 6.3. So tangent squared theta plus 1 equals secant squared theta. Tangent squared theta plus 1 equals secant squared theta. So I don't have these memorized either. The only one I have memorized is the sine squared and cosine squared. So tangent squared theta plus 1 equals secant squared theta. So let me bring this. Okay. This is good. I have a secant and I have a tangent. I want to rewrite this as secant so I can replace it in my fraction. So what I'm going to do here, I need to get rid of the square. And to get rid of the square, I square root. So it cancels. When I square root, I must put plus or minus. So this is going to become 1 over, and in place of secant, it's plus or minus tangent squared theta plus 1. You cannot cancel the tangent squared. That square doesn't go away. You have a plus 1 here. That is going to stop you from being able to cancel the root and the exponent. So be careful. Now, this is what I was looking for. I wanted an expression that had only tangent. So cosine was 1 over secant. They're all equal. And then secant, I was able to rewrite using a Pythagorean identity. Now, everywhere I see tangent, I can put a u. So 1 over plus or minus u squared plus 1. Now I'm done. I've rewritten this using u. There's no more sine, cosine, or tangent. It is strictly algebraic. You do not need to worry about rationalizing your denominator right now. You can leave your answer as is. All right, let's move on to the next one. Cosine of theta equals u, which means we want to rewrite tangent with cosine. So let's see. Tangent theta. The first thing that comes to mind for me with tangent, and I hope it does for you, but it's okay if it isn't right now. This is just getting our head thinking, how can I rewrite something, and looking back at the reciprocal identities and the quotient identities and the Pythagorean identities, and constantly keep looking at them. Tangent is sine over cosine. Hey, that's good because right now I have a cosine and that's what I need. So sine I need to rewrite. Well, there is a Pythagorean identity. This one I have memorized. Sine squared theta plus cosine squared theta equals 1. I want to replace sine, which means I need to get sine by itself. So I'm going to start by subtracting cosine squared theta. Sine squared theta equals 1 minus cosine squared theta. And just like in the last one, I can square root. Just don't forget to put plus or minus. So sine of theta equals plus or minus the square root of 1 minus cosine squared theta. So this actually can be, this whole piece goes in for sine. 1 minus cosine squared theta all over cosine of theta. And now everywhere I see cosine, I get to put a u. Plus or minus 1 minus u squared all over u. I have no more sine, cosine, or tangent, and I have replaced all the cosines with u. All right, I have one more. Cosine u. So sine of theta needs to be rewritten using cosine. We just did that. So let's look back here. Sine of theta is plus or minus the square root of 1 minus cosine squared theta. Now I can replace cosine with u. So plus or minus 1 minus u squared. And that one is done. It's going to take practice. You're going to have practice for a couple of weeks now on seeing what you can replace something with. Take your time as you're going through these, you guys. Always have your identities available. Don't make the same mistake that I did, not having my Pythagorean identities. Everyone always remembers sine squared plus cosine squared equals 1. It's the other two that we don't use as often, so we don't quite remember those. You will be getting a trig identity sheet for 7.3 that will have all of this stuff on it. So you will have one nice place to keep referencing back to. All right, please make sure you come with questions tomorrow if you have them, and ask them as we are going over this section in class. And please make sure you are doing your work for 7.1 and 7.2. All right, I will see you tomorrow.